Now in a cosine function, the x-axis still represents the angle, but the y-axis now represents the cosine value, which of course is adjacent over hypotenuse. On the unit circle, the adjacent side is the x-coordinate, so it's the x-coordinate on the unit circle. Now this is a little harder to picture than the sine, so I want to look at a couple graphs on decimal. So here is a sine graph. As this circle travels around the unit circle, notice what's happening to the opposite side, or the vertical side of the triangle, and then how that corresponds to the graph being traced here. So notice the vertical side is increasing from 0 till we get up to 90 degrees. By the way, these are alternate labels for the angles we'll talk about tomorrow, or not tomorrow, but later on in this unit, but this is 90 degrees. And then we go down. Now the vertical side is getting smaller and smaller, so when we hit 180, the vertical side's 0 again. Then now the vertical side's negative, going down to its low of -1, and then back up to 0 at 360. Okay, so we can see that the vertical side on the unit circle corresponds to the y-coordinate on the sine graph. Now let's look at cosine. Cosine is slightly different now. Cosine, the value on the cosine graph corresponds to the adjacent side, or the horizontal leg of the triangle, on the cosine as we go around the unit circle. So notice here the adjacent side's 1, here the y value is 1. So it's kind of weird because it's the x-coordinate on the unit circle corresponding to the output, or the y value, on the cosine graph. So notice what's happening to the adjacent side. It's getting smaller and smaller and smaller, and when we get to 90, the adjacent side is 0. Now the adjacent side is negative, so we see the cosine graph is going below the x-axis. So the negative side, and now we get to -1 at 180. Now the cosine value is still negative, but the size of the adjacent side is getting smaller, until when we get to 270, the adjacent side is 0. Now when we go into quadrant 4, the adjacent side is positive again, so now we're going back up to a high of 1 unit at 360. So notice that the adjacent side, or the horizontal distance here, is corresponding to the vertical distance on the actual cosine function graph. So if we go back on and we look at our unit circle, now what we're going to do is we're going to look at all of the x values. So let's see what's happening to the x values on the cosine graph. We see that when we're at 0 degrees, the x value is 1. Then when we're at 30 degrees, we're at square root of 3 over 2, or 0.87. At 45, same as sine, 0.7. At 60, 1/2. And at 90, 0. So instead of going 0, 0.5, 0.7, 0.871, we're going 1, 0.87, 0.7, 0.50. We're going the other direction with our numbers. So if I go through, oops, wrong one. If I go through and I got to find my value where I was. There we go. Highlighter. So if I go through and highlight all my x values, now we see they're negative in quadrant 2. All right, we go into quadrant 3. My x values are still negative, 0.87, 0.7, 0.5, and then 0, but they're all negative, and then 0.5, 0.7, 0.87, back up to 1. So if I were to make a table of values for cosine, my table of values would look something like this. So you might kind of want to keep your unit circle in front of you right now, and then as I look at my cosine graph here, my cosine graph would be something like, here's x and here's y. So I start out with, at 0 degrees, I'm at 1. At 30 degrees, I'm at 0.87. At 45 degrees, 0.7. 60 degrees, 0.5. 90 degrees, 0. So these are the x coordinates, x on the unit circle, that go with each angle. But they're the y values on the actual cosine graph. Okay, so let's plot some of these points. At 0 degrees, the adjacent side is 1. At 90 degrees, the adjacent side is 0. At 180, the adjacent side is negative 1. At 270, 0. And at 360, back up to 1. Now, let's look at all of the angles that have a 30-degree reference angle. Those are the values where cosine is either 0.87 or negative 0.87. Because if we look back at the unit circle, at 30, 150, 210, and 330, the adjacent side is still pretty long. Okay, it's not 1, but it's 0.87. It's a lot longer it's longer than it is not long, I should say. I don't know if that's a good way to put it, but anyway, 0.87 and negative 0.87. So we're looking at all the angles that have a 30-degree reference angle. So 30, 150, which would be, 30, 150, which would be negative 0.87, 210, and 330. Okay, so these are all where the adjacent side of the triangle is pretty long. Now we go to the 45-degree angles. The 45-degree angles are 0.7, just like they were for sine, because it's the square root of 2 over 2. So 0.7, negative 0.7. So 45 degrees, 0.7, 135 and 225, negative 0.7, 315, positive 0.7. And then the ones that have a 60-degree reference angle, this is where cosine equals 1/2. So 0.5 or negative 0.5. So 60, positive 1/2. 120, negative 1/2. 240, negative 1/2. 300, positive 1/2. So there's the shape of the cosine graph. Once again, above the x-axis, it curves down. Sometimes it's helpful to even draw both of those curves first. Below the x-axis, it curves up. So this is what a cosine graph looks like. It's sort of a curved bowl shape. But to give you a little phrase that might help you remember the shape of one cycle of the graph, I say that cosine is a cup that starts up. Cosine is a cup that starts up because it starts at its highest point. At 0 degrees, we're at 1. That's the highest that cosine can go, so it starts up. Now we're going to move on to tangent.